Ah, kids, now we're going to do concave lens ray diagrams. Remember the key. Go back to your demo, the picture. So in this case, it spreads the light out, but remember, it's like it comes from this focal point back here. Remember, this is a virtual focal point, which means that F is negative. So just keep that in mind. But let's draw a ray. So again, first ray, parallel ray. So we draw our light ray coming in parallel. And then it's going to bend up, but it doesn't randomly bend up. It bends up as if it came from this focal point. Now, because I already know it's going to be a virtual image, I'm going to dot it, but this will also help us know that it's coming from that focal point. Again, we're drawing these dotted lines because the light's not actually going there. All right, so we already have this one. Now, here's where this next ray, this focal ray, is maybe the most confusing of all of them. So if you look, parallel bends up as if it comes from this focal point. So I'm already using this focal point. Now I need to use this focal point. So that means it goes towards the far focal point and then it comes out parallel. So if you look, do you see how I'm lining it up with the far focal point over here? That's what you want to do. You want to line it up with the far focal point. So I'm going to draw that ray. And then once it hits the center, then it's going to come out parallel. Okay. And then, so that one's probably the most confusing one because it's not quite exactly straightforward. And then the last one is your center ray, which is super easy because it just goes through the center and goes straight. So there, and there, and there. All right. So now, hey, look, these light rays don't meet over there, but we already knew they weren't going to meet because a concave ray or concave lens always gives us a virtual image. And if you look, I extended this one back already, and this one, if I extend it back, it's right here. So you can see where my image is going to be. It's right there. But just to check it, we'll extend the red one back, and we'll see how we actually did. If I extend the red one back, hey, look, I did pretty darn good because my image is right there. Make sure you draw it. Virtual image. Okay. And then if I wanted to use the lens equation, I'm assuming this is 11 still. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, it's like not exactly 11, but it looks like it's 12. I don't know. You know what? I'm going to use centimeters because I don't like, I'm getting tired of counting boxes. So let's use centimeters. So my SI in centimeters is 7.5 centimeters. That's way nicer than trying to count boxes. 7.6 centimeters. Okay. My F, if I measure to the center, looks like it's 3 centimeters. Did anybody catch my mistake yet? All right, well, if you didn't, that's okay. We'll find it in a minute. Let's do our 1 over SO plus 1 over SI equals 1 over F. If I plug this in, 1 over 7.6 plus 1 over SI equals 1 over 3. Well, if we plug this in and we do the math, 1 divided by 3 minus 1 divided by 7.6, and I get this number, and then I take the inverse of that, and geez, it seems like I get my SI should be 5. Well, let me measure this out. Oh yeah, that's definitely not 5. Oh, wait a second, and I got a positive number. That would mean it's a real image, but this is a virtual image. Oh yeah, this has a virtual focal point, so I got to use a negative. Negative. Very important, okay? So let's try it again. So 1 divided by -3 minus 1 divided by 7.6 equals this. Take the inverse, and you get SI equals -2.15 centimeters. And if I measure it, that is almost spot on, 2.15. Wow. All right. And there's another one here, but don't worry about it because they're all the same. So if you can draw one, you can draw them all, but make sure you practice. Bye, kids.